Hello.
Hi, Jason.
Hi, Jason.
Hi.
Just can you increase the volume, please?
Yep.
Thank you.
Can you hear me okay?
Yeah, now that's fine. I'll just share around quickly with the round table. I'm Robert. I'm the host of this table of discussions. Here are the participants.
I'm David. I was organizing and we were chatting before.
Okay.
Hi, Peter, an interested student.
All right.
Frank. Hi, Christoph.
Christoph.
I'm Ben.
Franzi.
And back to me. You will probably hear my voice most, but since most people are kind of in this direction, maybe we can get a view of people like this.
Okay, I can hear your voice just fine. There's a little bit of interference with the other people, but see how it goes.
Can you hear me?
Yes.
So I was just trying to summarize the previous rounds, but I guess this will take just too much time. I guess I'll focus on the open questions from the first round and then just continue with the next rounds. So in the first round, we ended up with 3 unanswered questions. The first one is there a good, free, online, modern C++ tutorial? Do you happen to know anything about this?
A good, free, modern online C++ tutorial.
Yes.
Not that I'm aware of.
Okay.
Everyone that I'm aware of, and I can't even think of anything specifically at the moment, but anything that comes up on CBPcast, which occasionally we discuss when there's some tutorial or whatever that people are talking about, they end up still like have holes in them and promote things that are from like C++ 98 or were even not best practice even 20 years ago. So no, I don't have anything off the top of my head, I'm sorry.
Okay. So yeah, we also didn't come up with anything there. So another question that was still open at the end of the first one was how to know about the limits of tools. So when you have a certain like a feature of the language or library or a compiler or something like this, you need to know, for example, for a library feature, you need to know the performance characteristics. But how do you actually learn about this? I mean, normally you just know vector, but then you eventually discover that there is a growth factor that is not well suited to your application. Is there a general way to know about the limits of the tools that you use? Also, that's also asking the table around here.
Oh, okay.
But if you haven't any answer, just feel free to answer. So,
It's a strange question. I would not understand that.
Experience.
yeah, so is there a good way to get experience with the tools that you use?
Use them?
Use them, yeah. I always have. I mean, all of my paid work has been cross-platform, personally. But no matter what I'm working on, I always have a Linux VM open where I can quickly and easily like go to GCC and just try stuff. And that's, I feel like, how I've learned most of what I know about C++ is like, whoa, what's going to happen here? And then you experiment with growth factors and your vectors and see if different compilers are different. And having multiple compilers available to you at once helps a lot.
I also have always a playground project open in my IDE, and if I want to try stuff, I just do it there. It compiles in milliseconds, not minutes, like my usual project.
Right.
Try stuff there.
Okay, so I guess next question then. What do you do when your good C++ techniques that you want to apply have the downside that the compile time increases too much?
Does that happen?
Yes. Just include boost speed, boost G or karma or something like this.
Yeah, but I'm not certain that that's the best idea. I mean, abusing syntax overloading is not necessarily the best idea to do it.
But even if you just consider the standard library, including the standard library, header includes your makes a compile time from like half a second for an empty file to, I don't know, 5 seconds for a file that just includes vector. Things like this happen.
How much do you get increased by including vector?
So if you include vector, you get several tens of thousands of lines of code
Yes.
that you have to compile.
And how much does this actually increase your compile time?
So I measured this once on Windows, and the difference was, I think, 4.5 seconds.
4 or 5 seconds?
Yes,
Well,
I mean it's a slow machine, I guess, but just the
Are
over.
we talking about a project with thousands of files where
No, one file.
How the heck do you get a compiler to increase the compile time for one file by 4 seconds by including vector?
I think in this case it was an ordered map, and on Microsoft this includes 60,000 lines of code, and you have to compile all of this.
Then, if this is true, which I doubt, then my Visual Studio is broken.
I'm not shocked that it includes 60,000 lines of code. I am a little surprised that it increased it to 4 or 5 seconds, personally.
Yeah, I think I remember this correctly, but I might be wrong. I know that the overhead of just running the compiler on an empty file was 500 milliseconds, which is probably just process, opening overhead, and then I don't know what it was. And then it raced to several seconds when it just included unordered map. But this is just an example of how ordinary good C++ techniques can increase your compile time.
I can assure you that with GCC Linux, this does not happen. So,
can I make a different example other than including vector?
Sure.
Because I was actually just having, I was just thinking about this because of a conversation I was having with someone else. Constexpr. If you want to constexpr everywhere you can, that means moving more stuff into the header.
yes.
Which is then going to necessarily also increase your compile time.
Yes.
Maybe not orders of magnitude, but it will have an effect. So I can just pose this question to you guys too. Like, what do you think? I mean, I use templates, I use constexpr all over the place to get the compiler to do as much work as I can. That does have a real cost. And I think that's in the spirit of the question, if I'm correct.
Yes.
So I don't have an answer, but I was just throwing that out there.
Well, another problem that you have by moving stuff into the header is that now you have mixed declaration and definition. And if you have a nice C-level header which just states, hey, we have this 10 functions in this module and just the prototypes of these, that's essentially an overview of a documentation. If I now inline this thing with constexpr and add all the definitions in there, now there's no overview anymore.
Right.
So that's also a thing that goes missing by doing so.
But we can't throw it away. The advantages of using the compiler like this are too great. So I personally think the answer is we just have to suck it up and be willing to take longer compile times.
So, any other opinions on this? Okay. So let's just continue with the next round, the notes I have for the next round. Yeah. So we're talking about what actually is a good C++ developer and what is a bad C++ developer. The question topic arises about using the standard library, and people seem to assume that if you're using the standard library, you're a good developer, or on the other hand, if you're not using the C++ library, you might be a bad C++ developer. How do you think about this? Is this necessarily true? Do you have to use the standard library to be a good C++ developer?
You should know the standard library, I think.
Well, it depends on the part. I mean, if you're saying, for example, not using the standard list because it's essentially useless, then that's a good thing.
You should know.
But, or for example, if you're saying another map is not good because it inherently needs to allocate object per pair on the heap inside of this map, but this is slow and therefore not using it, that's a very good reason. So, but then again, you have things like vector, which are pretty nice. If we ignore that there's no reason of array view available with vector, but maybe we will get it someday. So
The span should be in some of the TSs or the next revisions of the standard. Is it right, Jason?
I'm sorry, what should be?
The span, array view.
Oh, array view is not. String view is. Generalized array view is not.
Okay.
But it's only like 15 lines of code to roll your own, so throw one in and use it.
He rolls his own. He again rolls his own. Now,
Yes.
What's the point of
that? I did not realize. I thought array view was going to be in it until a couple months ago. I didn't realize that it was overlooked, or maybe I don't know if it was intentional. Oh, actually, no, wait, I do have an answer to this. Array view is not in there because of the arguments that come up when you go past one dimension.
Mm-hmm.
So we ignore the case of 99%, and because of the 1% which has more than one dimension, the 99% are gone.
Come to a consensus for the design for more than one dimension.
So I can tell a short story of mine about this. So I did actually roll my own array view at work, and two other people did, and then we tried to reconcile this. One developer did this, and then I did the code review and had like about 200 comments about it, and worked, I guess, 2 full weeks full-time on reviewing and redesigning the combined array view. So it was with checked iterators, I have to be honest, but the final thing was like 300 plus another 300 lines for the checked iterators plus 1,200 lines of tests or so. So
and each project needs to do this.
Yeah.
So currently I'm just using const std vector at each as a reference at each position where I actually would need to use an array view. And yeah, that's not great, but the alternatives is either roll your own vector or array view, or yeah.
Or pass iterator pairs.
I actually wrote my own vector that worked great until somebody else needs to understand the code. Which is, even if you perfectly design your own vector to perfection, the other guy will still not know how to use it because, yeah, he first needs to learn the Doku. So, I mean, I'm not the opinion that std vector is a good design, but it is at least a design that everybody knows, so we don't need to explain it up front.
I think about the question, is it good to limit yourself to a certain set of the language or the features and maybe learn how to write clean code with this limited set, or should you use everything? If there's something more advanced, you can do it more elegant with this new C++ 17 feature, then use it.
I guess this also depends on the team and what you're developing for, I guess. So if the team is open for new features and willing to learn, you can use some more stuff and explain it to them. If they're reluctant to use it and even complain when they see new features, then maybe it's not such a good idea.
Or you get a new team. There are, I was surprised at the lack of standard library support for the AVR. So there is definitely platforms where you're going to be limited on what parts of the standard library you can use also.
I guess the AVR, the microcontroller, has the problem of not having any exceptions, nor do they have allocations, right?
I think that is correct, but I don't think it's a technical limitation of the hardware. I think it's a decision by the library implementers. I could be wrong, because I've spent time playing with other tiny microcontrollers where you can do allocations and you can do exceptions if you want to. You just risk that your code will quickly go beyond the size of the flash that you have available.
Yeah, but I mean, it's a reasonable design decision that you're saying you need to manage your memory by hand because we do not have much memory, therefore you need to squeeze out every bit that you can.
Yeah.
But in case of memory is not enough for standard.
But I guess ABRs will go away anyhow because the 32-bit microcontrollers are coming, like the ST micro.
But related to that, I once heard a talk about somebody that works in the audio industry and was talking about the audio thread that feeds the audio data to the thread which feeds the speakers. And he essentially said that if you want to avoid hiccups in audio, you must make certain that the audio thread under no conditions blocks. Now, memory allocations, they need to have at least some mutex in them to allow multi-threading. So essentially what you're saying, in this audio thread, you cannot use new. And now you're essentially in the same domain, even on large computers.
Right.
Because authors are many restrictions, many senseless restrictions on modern hardware.
Yeah, but it's not senseless. I mean, it really is a problem if it blocks for more than a few milliseconds, then you get a hiccup in your audio. So that's not acceptable.
Should we talk about misrossi?
So getting a bit more back to topic of becoming a good C++ developer, there is one interesting thing that we discussed, and it was about character traits. Are there certain character traits that a good C++ developer absolutely needs to have, or that lead automatically to being a good C++ developer? And we came up with things like curiosity and laziness, also it's like proposing things, but yeah, you have to be lazy in order to discover simple patterns, for example. On the other hand, you have to be curious to learn about the language. You have to have discipline to test all the things that you do. So what do you think about these character traits?
I do not have any argument with those, and I might add, I don't know what the right word is, but someone who has attention to detail.
Yeah.
Because you need to think about what the compiler's doing with your code also. Is that fair?
Sounds fair.
So related to this thinking about what the compiler does, there was also some discussion about the level of abstraction. So for other languages, we determined. So we were discussing what is specific about a good C++ developer as opposed to just being a good developer in general. And one of the pain points was that C++ tends to have many levels of abstraction which you always need to consider. And on the other hand, you need to know when to go down to the bare metal and when not to lose the abstractions.
Right.
But if
That's.
Sorry.
Oh no, sorry. Go ahead.
If you do not need the bare metal at any point, then what's the point of using C++? I mean, if you never need to go down the abstraction hierarchy, then use something more high level.
So maybe the idea is then to know when to go down to the bare metal and when you should not overthink it, I guess.
This is why I always also have a compiler explorer tab open. If it's a technique that I'm unsure of, I try to program at the highest level I can. And if it's a technique that I'm unsure what the compiler is going to do with it, I always have Compiler Explorer open, and I see, like, okay, does this actually compile down to something simple? Great. I'm going to keep using the high-level technique.
Is that feasible even with complex projects? Jason?
I think so.
If you have like thousands of files and several components interacting with each other, is this still something that you can apply?
I think the only point where it falls down is once you start to get to a certain complexity. If you're relying on the compiler doing constant folding and inlining of your code to make it all just go away, once it reaches a certain complexity, you can no longer promise the compiler is going to do that, even if you know it's capable of it. And then you start doing like, well, what happens if I type inline here and it changes things a little bit in your final build of your giant project? I hate doing that personally because inline's just a hint anyhow. So I end up, yes, sometimes it falls down, but I feel like 80% of the time it's a good way to play with new techniques. But like anything else, you have to test it and measure it in your actual project too. I mean, you need one of those 360-degree cameras so I can see what's going on behind.
I can also like move you a bit.
I mean, there are also people there, so.
So I can try this.
Oh, look, more people.
I just hope that the voice will get through.
And if I can, is that beer that everyone's drinking?
Not really. That's lemonade.
Oh.
But if you want to drink a beer, just go ahead.
I was just going to commend you on your German beer drinking C++ meetup. It seems like
No beer, sorry.
So we're also getting a point about having a mentor, and if you cannot get a mentor in person, that you should get a mentor from somewhere else, like from books or tutorials or videos or something like this. But if you're a beginner, it's hard to tell about the quality of things. So how do you know when you're not an expert how good a book is or a tutorial is on the internet or video?
Wow, that's a really good question.
Well, in my opinion, reading a book is maybe good. A book is maybe good if you consume much time on one page, only to understand what he reads, what he writes, and to learn the information you receive from him. Like from Jeff Myers also, the pages have many information, and well,
so it should be terse, it should be packed full of information on very little space.
Or you have to traverse very slow on the page or in the book, and you have to gain.
You think that's good? Or?
Well, it's good to have meaning of you learn from.
Okay, but I would also be somewhat frustrated.
Yeah.
Thick book and I read half an hour for each page, then I probably won't read it.
But not on understanding of sentences or something like that. Only on the information that's given.
So essentially you're saying a lot of information per sentence.
No
Not
BS,
really.
more or less.
More yes, but that's
I mean, what you're saying goes a bit in the same direction as people usually say that you should do scientific writing, where you're saying easy, simple sentences, and every sentence should have
one information.
one or perhaps more information. One is probably better, and avoid buzzwords as much as you can.
Right.
So this gives you normally pretty easy to understand text on the English level, and usually also comparatively compact.
So that all your mental energy you need to, you can pour it into understanding the information and not the language.
Yes, that's what I mean.
You essentially want to write in a way that your English teacher would say, that's bad English.
So, yeah, Franzi, you want to say something?
I'm not sure. So some books are good, some are bad, but they are also written the same way. So it doesn't necessarily mean something about the book. But I think, learning from projects which are already exist is maybe a good idea. So maybe a book is good for starting to get the language itself, but learning good coding is maybe a good thing to look at projects which are open source projects, for example. So that would be my opinion. So maybe it's wrong. I don't know.
I think I can apply the same question on the project. So first of all,
Yeah,
how do you
okay.
select the project?
That's a good question.
Such that you find a good project, and then also how do you essentially get into a project that is reasonably complex? So you can learn some things from simple projects, but there are some things you can only learn from complex projects. And how to get into a project like, for example, LLVM, which is huge.
But maybe
This
these
is
are the
open
live.
question.
Yeah, this is maybe you have like a problem you would like to solve, and you use something, and then you can check out what, for example, how the library is written, because you use it because it's good. It's the best you can find currently.
Which does not mean that it's good.
Yes, but it's, you would like to learn. Yeah, you cannot start at, you cannot you cannot think of starting at the highest level. So it's like little steps you make. It's not like you cannot always.
Are we talking about learning C++ in general, or talking about learning how to do a specific task at a time?
I guess both contribute to being a good C++ developer. Or
Because
don't
if you're
they?
just looking for examples which use C++ in general, then I think a pretty good indication for a good library is, does it have a reasonable documentation? If it does not, then my experience is that the code will also be a bit rotten.
Well, okay, so on the specific example of LLVM, which I do not know how it's documented, but let's assume that it's documented very well. LLVM, for the sake of this argument, LLVM rolls all their own containers and has exceptions turned off globally. Is this the techniques that we say are a good project that everyone should be learning from?
Well, the Google guys say yes.
I think
Because that's the reason why it's turned off.
I think the Google coding guidelines have a disclaimer which says that they apply for in-house and you can learn from them, but they should not be applied generally. I think Google has problems with exception safety, which come from legacy code, and therefore they forbid the use of exceptions.
Yeah, but also new code that they write, they do not even try to make an exception safe. That's another way of solving the problem.
True. So I guess you have to understand why a certain project chose certain limitations. Like LLVM, I guess they have a reason for writing their own containers, right?
Yeah, for efficiency, they have all their own small vector and small string and stuff like that.
So you learn from the project not just by looking at the code, but also at the decisions, the design decisions, I guess. But it's not that you can just open a file and directly learn something from it that is good and applicable.
The experience that I've made we were talking about books earlier. The experience that I made with books is that they need a year or two to write. Then it will need another year or so until we find them. And so they're always behind the state of the art.
Yeah, but you learn from the decisions. So usually they're not talking a lot about the language. They usually say about design decisions. So
it depends on what abstraction level they are talking about.
Yeah,
if we're really talking about C++ language features, then
Okay, great. Thank you. Thanks a lot. Yeah.
they're always inherently outdated.
Bye.
I mean, these books you shouldn't buy, basically.
Yeah, but if every book is inherently outdated and you're saying I shouldn't buy outdated books, then you're saying I shouldn't buy books.
Yeah, maybe not about the language and the features, because this you basically find on the internet.
So I wish you a
I guess
nice rest of the
best
day.
way to find it there.
Have a good
And
time.
about design
And
decisions,
thank you.
how you
Bye.
yeah.
The thing that I don't think that you always find in the internet or is how specific language features interact. For example, you might learn about Otto, you might learn about lambda functions,
Yeah.
but the fact that both in combinations give you essentially local functions.
But you learn this while programming.
Yeah, but I don't think that you will notice by yourself that you can stick an Otto and a lambda function together.
Okay.
Because I don't think that this is, I think, a sufficiently complex
I
and
see
different idea.
I see many people using std functions because maybe they're familiar with this from C#, which is a similar concept. And then they combine lambda functions and std functions.
Yeah, but that's actually what you do not want to do because
Yes.
you're losing inlining by doing that.
Yes.
Although I think it can still inline sometimes if your function falls into
sometimes,
the small function optimization and everything's known. I think it sometimes can elide away the function.
I guess it has to
then
do.
the compiler needs to de-virtualize the call.
I guess it has to do with concept.
It can, yeah.
I guess if your std function is local and you do not leak it anywhere in
Right.
the function, then and you have
Maybe.
optimizations turned on, then and you're playing and the moon is white, then yes.
Yes, okay, so to be clear, I was not trying to advocate for using std function. I was my brain wouldn't, wanted to discuss, I think sometimes it can. So
I'm pretty sure that I've seen it, but yeah, it should not be relied upon, I guess.
It's relatively common, that's the scary thing.
That people use it or that it's
That
inline?
people store lambdas in std functions when they really shouldn't do it.
Right.
I've seen it multiple times, especially in questions in online forums, but it's scaring me.
Am I correct that you need to store the std function to be able to do recursion?
to do what?
Recursion.
Oh, I think people have come up with tricks that don't require that, but I could be wrong.
Okay.
I think it depends. If it is a stateless lambda, you could also use a function pointer.
Yes, of course.
I guess you can always call yourself by using this pointer and then the overloaded apply operator.
I'm not sure if you can
But, yeah.
access that from lambdas.
If you make
Yeah, you're right, because you would capture the name from the outside. You're right. Yeah, that's true.
if you make a generic lambda, then you could pass yourself as one of your parameters, right?
No, I don't think that you can do that because the name of your Otto is being deduced while you're writing your lambda, and therefore I don't think that you can actually refer to that name because it's not.
Maybe not.
Yeah. I remember this. Do you know Johannes Schaub?
No.
He was one guy in Stack Overflow, has many reputations. He asked this once because he tried to use a lambda function recursively, kind of, and he did not succeed. And the reason was that he tried to deduce the return type using the lambda function itself, which does not work. It creates a cyclic dependency.
Right.
So the return type of lambda function that depends
So the
on
big
itself.
question is, do you need to know that fully level to be a good C++ developer? you maybe should.
I think you might be able by using generic lambda and the first argument as a reference, as autoreference, and then pass the variable itself to that and use that in recursion by calling itself. It's no matter what you do, currently it's nasty. I think there was something about a standardization proposal to ease the burden a little bit, but I could be very wrong about that. But everyone agrees it's nasty.
Yeah, okay.
So, Jason, do you still have time because it's already 10 p.m. here?
I still have a few minutes, sure. I did have a quick question, if you don't mind, for your group, since we were just talking about books. Sure. And I've heard people comment that they only read programming books in English because of the risk of translation errors. And I was just thinking, if you were going to wait for a non-English translation for a book, you were already saying it takes a year to write a book and then a year for you to find out about the book. And then how long does it take for there to become a translation? Now you're really talking about an out-of-date book. So
I would not buy a book in German programming book.
I would understand
You
none
would
of the
not.
terms.
Yeah, they're full of silly bugs.
Yeah,
Actually,
Strange bugs that gives you the wrong direction.
Actually, I can. When I started programming, I was using Windows, and that was still French, but the point doesn't matter. But then they actually translated all of the error messages that their API provided to French. And then you got an error message, and you knew absolutely not what they were talking about because they translated each of the words quite literally, and it was.
By the way,
that's interesting.
This also concerns compiler. In a normal German Visual Studio setup, you'll get a German error message that is very hard to Google.
Similar things are applied for GCC if your system is not set to English language. And I used to have German Linux for a very long time, and I think my current computer is the first one that is set to English by default, and I'm lying about the country I'm in, but that way I don't have trouble, because it starts with things like this. Normally you have a nice UTF-8 local, and it uses all the fancy Unicode characters like nice typographic quotation marks and everything, and then you can brute force it by local equals C, and then it will use English, but it will lose a lot of features. And another thing about translated programming books is that, of course, they tend to cost a bit more because someone had to translate them. And if I'm fluent in English, why the heck would I spend extra money?
Spend extra money on a book that probably has bugs in it.
That's not even, I mean, I started learning C++ basically with the German wiki books. This was really my initial real source, and it worked. And it's not great what they have, but it's some of the less terrible versions. So I don't mind German books, but I don't see a point in wasting money on a translation that I don't need.
So do you all, I know throughout Europe, taking English classes is normal. You're required to. But do you all speak English better than you would otherwise because you're programmers?
Yes.
So would it be fair to say, now that I just thought of this, that one of these keys to being a good C++ programmer is understanding English?
Extended to being a good programmer.
Yes.
The most nasty thing that you can imagine in programming is code not written in English.
Have you seen Russian variable names or Chinese variable names? That is not very easy to understand.
No, I haven't.
Yeah, which are not allowed in C++ comments.
You can use them. I once created an underhanded C contest program that it's a contest about creating subtle security flaws that no one will find. And I used something like I changed normal O in a string to a Cyrillic O, which look exactly the same. And so the program it does completely the correct thing, but it was very evil in what it did. I failed to pass it in at the right time, though, but it works. And you can, and I've once encountered a situation where actually Unicode is nice, and that is if you use physics units like square meters and use the defined literals, you can write m to the power of 2 with the power of 2 Unicode character. That works, and it's nice.
Interesting.
So to get another slightly different perspective on this, I think it's also important to know English, not just for asking questions online or for searching for things, but also to get into more export level stuff. So when you start reading the standard or start reading proposals, you have to know English. And if you know only the German terms for stuff, like data members or something like this, then you have a hard time understanding anything. For me, it's the reverse. I mostly learn with English stuff, and now if I try to read German stuff, I don't understand anything because I don't know the terms at all.
That's amazing.
For many things, I think there are no German words.
You don't know how the imaginative people.
Don't remind us of them. They are horrible.
I usually encounter this at university when we have
At
German.
university.
Are you talking about a very certain professor at this university?
There are professors that need you to say Erbauer for builder and
Kellerspeicher.
Binder for linker or Kellerspeicher for stack. Stuff like that.
Want you to send them an
Absolutely evil.
At least
Makes
they
no
stop.
sense in business. No sense. No one understands you.
Especially because Keller actually means basement. So we're translating stack with basement.
Okay.
Because we're not putting things on the top as in a stack, but we're putting them in the basement and we're taking all of the basement.
I would, however, make it.
Why ever somebody comes up
I
with
think
this
the
name?
term is older though and comes from theoretical computer science, and I wouldn't bet that it isn't older in German than in English, but there are many where it's idiotic. I mean, the worst one is Weichware, which is the literal translation of software, which already in English is pointless.
It's kind of a fascinating turn of events, since computer science is based in math, and a lot of the original old math terms come from Germanic languages and Russian languages and stuff, and I don't know. It seems kind of funny to me.
Yeah, sure. I mean, I could go on and on and on with the questions. So once we touched upon the topic of dark matter programmers, which I think is a term coined by you, Jason. Is that right?
Oh, no, I didn't coin it.
Okay.
Someone else did. I might have repeated it at some point.
So
Who coined it? I don't remember where I heard it. Sorry.
Okay. And some of us got the impression that dark matter programmers are more abundant in C++ than in other programming languages. So this is, I think, a point which one could discuss on its own. But what does it actually mean for being a good C++ developer? For example, for the community, a dark matter to explain for those people who are not familiar with the term, dark matter programmer is someone who takes input from blogs and reads books and so on and learns about things, but does not give any of this back to the community, does not write blog posts himself, does not teach, does not spread the information. So how detrimental is that to the community? How bad is it? Can you still be a good C++ developer when you're a dark matter programmer?
Yes.
I
know some.
It could be a good one. I mean, being good at something and being nice is two different things.
I also say someone has to do the actual work. Not everyone can teach.
I do think, though, that the people who don't participate in IRC or on Slack or on any of the forums, the people you just never see, seem to be exposed to fewer ideas and less aware of where the community is going with best practices. But I don't know how many of these dark matter programmers are lurking on IRC or whatever and reading all of the blogs and just never, don't mention anything in public. You don't know they're there.
So another aspect would probably be that you cannot get really code review from an entirely different point of view for a dark matter programmer. You might be in a team, and you might get input from outside, but you cannot evaluate your own ideas, I guess.
Right.
Yeah. They don't get feedback for their work.
But it does seem like the C++ community, we know that there are tens of millions of C++ developers around the world, and you total up everyone, and you've got, 2,000 that go to conferences? It's not that many people that are, out of curiosity, you guys all going to meeting C++ this year? Have you bought your tickets yet?
Too many different ones.
Well, where are you right now, actually? I'm curious.
In Karlsruhe, this is in the southwest of Germany.
Okay. So about as far away as you can get from Berlin, but still.
Well, 800 kilometers.
At least we rescheduled one of our C++ meetings to enable going to meeting C++ without missing a meeting from our C++ user group.
There you go.
So we're aware of the conferences, I guess.
I don't know.
So
I'm like kind of hyper involved with everything right now because of all the stuff I'm involved with. So it's hard for me to get a perspective necessarily on what the person who's going to work 8 hours a day is doing.
So
since I work from
how
home.
many of us do actually watch the Meeting C++ or the CPPCon videos?
A few of them. To very much,
Not every, because you need a full-paid job to watch all the videos.
Yes, some are actually just bad.
So actually, I managed to watch all the videos from CPPCon 2015, but like only a couple of the 2016 ones.
How's that even possible?
I watched all the CPPCon 17 videos because I was ill. I lay in bed.
It's like 110 hours of video or something.
So for me, I did this by speeding it up to 1.5 times to 2 times. Not kidding. It's possible. For most of them, 1.5 times is perfectly well understandable.
That's
Yes.
the German standard feature.
No, but
I at least watched all the Going Native talks, and I think personally my impression is that the quality went a little bit down after they introduced CPPCon and went from the Going Native format. So this may of course be because CPPCon has a lot more range to it, what they are talking about.
Yeah, and Going Native was a smaller conference with, I think probably hand-picked speakers compared to, yeah.
Oh, by the way, a hint to presenters. It's easier to watch at 1.5 to 2 times speed if the presenter has a clear pronunciation and does not vary much in the speed of what they're talking. That's not necessarily you, but other presenters did this. They speak very quickly and then they have long pauses. And of course, you want to skip those long pauses without having them speaking too fast, and they actually do speak. So that's when you have to slow down to 1.5 times.
I've been told by an Italian and a German that generally I do well with keeping good pronunciation and a good speed. But my last talk at C++ Now, I think I spoke way too fast through that one.
Well, for me, I think this would be perfectly fine then. But
Speed is good.
no, if you meet some other presenters, you maybe you can tell them or something like this.
Okay, I will keep that in mind.
You can walk around, but you need to speak.
I don't think that anyone is aware, or that many people are aware that people are trying to watch their videos at a higher speed than normal.
I'm aware because people tell me they listen to CVPcast and my YouTube videos at higher speed.
Ah, okay.
But I don't. That doesn't affect how I present anything.
So, yeah, another question. Is there a gap between C++ beginners and experts, or is it just a perceived gap and there are actually many intermediate developers in C++?
Oh, so you're asking whether you go from beginner straight to expert, or whether there are...
Yeah, how does the learning curve look like? Is it a very steep curve where you just essentially immediately go from beginner to expert, or are you just essentially a dark matter programmer while you're being an intermediate programmer?
Beer.
What happened?
Beer!
I opened a bottle the German way.
So I guess the question came up when we were discussing questions on Stack Overflow or something like this. You see a lot of beginner questions and you see a lot of expert questions, but not very many intermediate questions. And of course, this might be just a perception, because if you're an intermediate level, you do not have many questions that you cannot answer yourself. But it might also be because the learning curve is so steep that you essentially are either a beginner or directly something like an expert. We have domain level questions that are very deep.
I feel like personally, most of the C++ developers get past the beginner curve and they're intermediate. Then they're like, well, now I know everything I need to know to get my job done. And they choose to not keep learning. Us. Maybe it's not a conscious choice, but they're like, well, I'm good. I know what I need to know.
Yeah, just focus on the work and get things done. And don't
Yeah,
spend any more time on learning the language, I guess.
But that's been, like I said, it's been a while since I've worked in a regular office environment with other developers. So I don't know if that's changed or if I was just in a bubble when the offices that I worked in.
The question is also if this is bad, because if the people know everything they need for their job, well, can you really call them bad programmers or anything? There is, of course, a need for some very extreme experts, like the people who implement the standards library. And of course, I expect them to know everything about the deep details of SFINAE and all this stuff. But 99% of programmers don't really need that, and it may be good that only a minority knows and understands and uses this, because this keeps it concentrated in closed libraries that hopefully have a good API so that your average Joe doesn't have to deal with the ugly internals.
And that's a good point too, is the people in your organization who are making the core libraries are probably a relatively small group. The bulk of your programmers are probably people that are using them, and you just want them to use it correctly, well. Maybe.
Here's an example. Half a full-time employee for essentially a copy of the STL, or the whole standard library, with modifications. That's the actual number from big company I work in.
Wait, what was the question?
No, this was a remark. In my company, there is a copy of the standard library which was done before C++11, kind of a fork, more or less, which introduced allocator support and some other things which they need tighter control over. And they had for a long time just half a full-time employee working on this.
Oh.
Which to me was very surprising. Now they have, I think, 3/4 of a full-time employee position.
So just that I got this correct, you forked the standard library?
I didn't. They did, but they had to. They had to introduce allocator support before it was in the standard library.
Before you forked the standard library, you roll your own vector.
That's kind of what they did.
But
hopefully in a different namespace.
Yeah,
okay.
Different namespace.
But one thing in that area I would like to mention is that if you look at the actual standard library, unless you really care about deep performance, a lot of it is surprisingly simple because it is that well designed that a lot of the functionality really is very simple function that just needs to call other ones. So
you're talking about libc++, right? Not libstd C++.
I'm talking about the standards, especially the algorithms header in general. They are not. I mean, of course, you can put an arbitrary amount of optimization into std sort, and you can, of course, also optimize std find. But it is relatively easy to write a working std find that is completely correct.
So
and once you have it, it doesn't need that much maintenance.
So my impression from libc++ is that it's quite well understandable. But every time I look into libstd C++, I'm very confused, starting with the indenting. But
I usually understand it, but yeah.
The stuff that either of them have to do to protect themselves by, like putting all of their identifiers, starting with underscores and all this, I just find it difficult to read regardless, unless I need to set myself in that mentality.
Yeah, that's true. What I was referring to with this half the full-time employees, that if you only have very few experts, you only can spend so much of their time for the fundamental libraries, which are very important. So getting a better programmer is maybe also required because they need just to be more experts. And even if you have enough experts, if you can learn more and therefore simplify your code more, maybe that's also a sufficient motivation.
But you need to be a top-level C++ programmer to write clean code, because it's also...
Yeah, that's true, but the more you know, the more you maybe can apply. I mean, you do not have to remember everything, but you should see many things to be able to see if they apply to the stuff that you do. And maybe then you find eventually some techniques that can you apply and that make your life easier. That's what I was referring to.
But I don't think application programmers should deal, not only should be able, but should not deal with, for instance, advanced compile time metaprogramming.
No, they should.
This is not something that you should do in that area, and you can be a great programmer there and still not know it. So it's really also a question about you are an expert in what.
Yeah.
Right.
So,
But it's better to know about it, because then these people get self-confident, and if they see something that's strange to them, then they see what's going on there, and they have an idea what they can
But
do.
the risk is if they, for example, know about substitution
Failure is
not
not
a
a
failure, or is a failure, I don't. You know what I mean? If a person just learned about it, you have the risk that the person go around and apply it everywhere.
but
And
then
then
not
the code
he's a
is
very good
absolutely-
programmer.
Then the code is absolutely unmaintainable.
That's right, but that's the reason why I have a source code management system, and then you can just
Yeah,
revert it.
I guess this comes down to discipline. So if you just acquired knowledge about a new feature, you should have the discipline not just to use it directly in production code, but play around with it, learn more about it, see it in examples, see what the disadvantages are, and if you feel confident about it, then you might be able to start using it in production code.
But I think you start at being a good C++ programmer long before you know all the details. The main problems that my impression is that you see a lot of the time is people writing Java with a C++ compiler, basically.
Yeah.
Or similar stuff. A good Fortran programmer can program Fortran in any language, but that doesn't mean that it's a good thing.
I probably should get off in a minute here, by the way.
Ah, okay. So thanks for joining us then, and thanks for answering the questions.
Thanks a lot.
Sure, no problem. Is this the only table left now going on or something?
Exactly.
Okay.
Yeah, so
Well, it was
it's,
fun joining you guys.
It's 10:30 here, so people are leaving. That's why.
It's
Not enough students around.
10:30 p.m. here.
Well, tomorrow is a bank holiday, so.
Oh,
All right.
I have no idea. Oh, just in time for my birthday, I guess. I didn't know it was a holiday.
You have birthday tomorrow?
My birthday is tomorrow, yes.
Oh,
Congratulations.
We're going to call you back tomorrow then, I guess.
You send me a note, sure. That was a lot of fun. Thank you for inviting me.
Thank you.
Bye-bye. I have no idea how to end